Hello everyone. This is Lab 1 Matter and Measurement Concepts. Mm, what is chemistry? It is the study of the matter. And what is matter? Anything that has mass and takes up space is called the matter. Now, there are three states of matter: solids, liquids, and gases. Solids have definite shape and definite volume. They are incompressible and they have strong forces of attraction between the particles. Liquids have indefinite shape because they take the shape of the container and definite volume. They are slightly compressible and the forces of attraction are weaker compared to the solids. Gases have indefinite shape and indefinite volume, compressible, and they have weakest forces of attraction between particles as compared to solids. Now, we can also classify the matter as pure substances or the mixtures. And again, your pure substances can be elements or compounds. So, this uh, for first look at these elements. All the elements that you see in the periodic table, they are pure substances and they cannot be broken down to another pure substances by any change. For example, if you have aluminum foil, it's made up of aluminum and there is no other element in here. Copper wire is just made up of copper. If you will cut the copper wire into pieces, it's still going to be copper. On the other hand, if you look at H2O and NaCl, these are the compounds and they are also the pure substances. Water, where hydrogen and oxygen are combined in the ratio of 2:1. And now it's not hydrogen, it's not oxygen, it is water and it has its own properties. And you cannot separate hydrogen from the oxygen by any physical change. Uh, when I say physical change, that means by melting or by boiling, you cannot uh, convert water into hydrogen and oxygen. Similarly, sodium combines with chlorine in a ratio of 1:1 to form sodium chloride, which is the salt. It's a compound. It does not have the properties of sodium and chlorine, it has its own properties, and sodium cannot be separate from chlorine by any physical change. Mixtures, on the other hand, their composition can vary. For example, if you take salt and mix it with water, now it is a mixture. And how do I know it's a mixture? Because they can be separated by a physical change. For example, if you have solution, salt solution, if you heat it, the water evaporates. What is left in the is the salt in the beaker, and then you can even condense the water back, and now you have the separate salt and water. There are two types of mixtures: homogeneous mixtures. They are uniform throughout. What it means, if you take a pinch of salt and put it in the water and the salt dissolves, now you cannot see the salt and the water separately. That's homogeneous. Heterogeneous is, for example, the mixture of oil and water. Can you see them separately? Yes, you can see two separate layers. That's heterogeneous mixture. This is a very good flow chart for the um, pure substances. So you have a matter. If matter can be separated by a physical process, then means it is a mixture. If it cannot be separated by a physical process, then it's a pure substance. And again, physical processes are like melting, boiling, and so on. Now, once it's a pure substance, then uh, can it be broken down into simpler substances by a chemical reaction? If it is yes, then it's a compound. If it is no, then it is an element. Because compounds can be broken down into their elements by a chemical reaction. We're not talking about a physical change. Um, Now, some information on the top here is missing. Um, it should be now measurements. The topic is measurements, and measurements have um, the numbers in the measurements have no meaning unless there is a unit in the number. Um, it's here. It was just hidden. So every measurement is composed of a number and a unit. The number is meaningless without a unit. If we say the mass of the object is 10, and if you're not putting the unit with it, then it has no meaning. We have a metric system, and we also have the English system or the American system. In metric system, you can go from one unit to another by multiplying or dividing with the um, 10 raised to the power something. But in this American system or the English system, um, for example, 1 feet equals 12 inches, 1 yard is 3 feet. You have to memorize these uh, conversions. So, metric system, for I give mnemonic to my students: kings have diamonds because diamonds cost more money. Kings, K's, kilo, hecto, D's, this is deca, and these are the base. Your length can be in meters, mass can be in grams, and volume can be in liters. This D is deci, centi, milli, and micro. What it means is that if you are going from kilo to hecto, you're going to multiply the number by 10. If you're going from kilo to deca, you're going to multiply by 10 to the second. So let's look in the problems. For example, here the question is how many grams of aspirin are in 325 milligram of tablet. So the very first thing that you do is you write down the number that is given to you in the question, which is 325 milligram. Ignore these significant figures right now, but we are going to discuss it very soon. And here is milligram, and you're going to write down the same unit down here, milligram, and you want to convert it to the grams, so grams will go here. So where are grams and milligrams here? So grams is here and milli is here. Then you see how many jumps you are making. So grams is bigger. If it's on the left side, it's bigger. So that's why we put 1 next to it. And then to go from grams to millis, how many jumps you have to make? So it's 1, 2, 3. 3 jumps. 3 jumps means 3 zeros. So that means now milligram cancels with milligram. 325 divided by 1000 gives you 0.325. Let's do another problem. If the density of acetic acid is 1.05 grams per ml, what is the volume of 5 grams of acetic acid? And here I'm giving you the formula that volume is equal to mass times density. So let's make a table here just to confirm it. Here is density, here is mass, here is volume. So volume, if you're calculating, then it is mass over density. it didn't seem right. So you have a mass is 5 grams, and then you have to write down the density. You're dividing it with the density, and what is that? 1.05 grams per ml. So now grams cancel with grams. So 5 divided by 1.05 will give you this number, 4.76194. But then you have to write down your answer as 4.8. If you're going to write it down as 4.76, it's wrong. If you write down 4.761, it's wrong. It has to be 4.8. So how do we decide how many digits we need to put in the answer? It depends on the numbers given in the question. So for that, you have to understand the significant figure rules. What significant figure rules are, that whenever we do the measurement, we have a number that is exact, that are exacts, but then they also should include one estimating digit. So if we apply these rules only on the measurements, we don't apply these rules on the exact numbers. For example, students sitting in the class, that's not the measurement, so we do not apply significant figure rules there. We apply them on the measurements. So let's look at first understand what significant figures are. All non-zero digits are significant. So here, how many significant figures will be in this number? 4, 2, 1, 2, 3, 4, 5, and 3. Now 0 is significant only if it is between two non-zero numbers, like we see it in this case. So this 0 is significant, so that means there are 3 significant figures. Or it is at the end of a number, but then there is a decimal point in the number. So here the 0 is at the end, but can we see the decimal in the number? Yes. So that means this 0 is significant. So 1, 2, 3, 4. Are both these zeros significant? Yes. These are the zeros at the end. And is there a decimal in the number? Yes. So this or both zeros are significant. So this also has 4 significant figures. A trailing 0, the 0 at the end in a number without a decimal point, is not significant. So here we have a 0 at the end, but there is no decimal. So there are 2 significant figures. This has 2 significant figures, 2 and 1 significant figure. What it means is, now how do you apply these rules on multiplication, addition, subtraction, division? So the first is in multiplying and dividing, the answer has the same number of significant figures as the original number with the fewest significant figures. So here, this is the last problem. We are multiplying these two numbers and to find the answer. How many significant figures are here? 2. How many are here? 3. That means in the answer you go by the fewer, means in the answer you need to have 2. So we come here and since we need only 2 significant figures, we will look at these two numbers. So we want 4.7. But then look at the next number, but only the next number. If this number is 5 or more than 5, then you increment the last number by 1, so that becomes 4.8 ml. In addition or subtraction, what you do, your answer has the same number of decimal places as the original number. So so let's say you are subtracting these two numbers, 10.11 minus 3.6. 10.11, how many decimal places are there? 2. And in this 3.6, how many decimal places are there? 1. That means your answer should have only one decimal place. So you will still subtract and you will get 6.51, but then you're going to just say 6.5 because you're going to ignore 1. Now had it been let's say 6.56, then what should be the answer? 6.6. Because if this number, the very first number that you are ignoring is 5 or more than 5, you increment the last digit by 1. So significant figure rules we apply on the measurement. Here, these things, one important thing that you need to know, that how to convert a standard number to a scientific notation or a scientific number notation to the standard number. So let's say if you have 2500, quotient is 2500 and 0.036, and you have to convert them into the scientific notation. So the first rule is that you have to move the decimal point to give a number between 1 and 10. So that means in 2500, if you cannot see the decimal, that means it is at the end. And where do we want it? We want it here. Because by this, we are getting the number between 1 and 10. So we want the decimal to be after the first non-zero numbers. Now, your decimal was here and you moved it here at this place. And so that means what you did, you moved the decimal to the left. How many places? 1, 2, 3. Then you're going to go and write down 10 to the power third. So if you're moving decimal left, your x, this value, the exponent value will be positive. Similarly, 0.036, where do we want decimal? We want decimal to be after 3. So here 3.6 times 10 to the power. Now you're moving decimal places, you're moving decimal to the right. How many places? 2 places. If you move the decimal to the right, your x value, the exponent value is negative. So it is going to be 10 to the negative second. So this is the way we convert standard numbers to the scientific. Density, we already discussed it a little bit. Density is the ratio of mass and volume. Mass and volume are extensive properties. What are extensive properties? That depend on mass. But density is an intensive property which is independent of mass. What it means, let's say you're finding the density of a copper, whether you take a big copper block or a small copper block, your density is going to come out same. A less dense substance floats on the top of the denser liquid. I like to give this to the students. I draw a triangle here and put D here, M here, and V here. This gives a relationship between density, mass, and volume. So if you have to find density, then it will be mass over volume. If you have to find mass, then it is density times volume. They are written next to each other. And if you have to find volume, then it will be mass over density. So it depends on the quotient. So if you look at this quotient, if a piece of rock has a volume of 0.73 liter and a mass of 1524 grams, what is the density of the rock in grams per ml? So we are finding the density, which is mass over volume. Mass is 1524 grams and volume is 0.73 liters. So when you're going to divide 1524 by 0.73, you will get 2087.6 ml1. But then since these are my measurements, that means I'm going to apply the significant figure rules, and here we are dividing. So the division significant figure rules are that you look at the original numbers, how many significant figures are here, 4, and how many are here, 2. Remember, 0 at the end is significant if there is a decimal, not on the starting. So this has only 2 significant figures, and you go by the fewer. That means I need to represent this number with 2 significant figures. Now for 2 significant figures, I need the first 2 numbers only, but since my next number is 8, that means this will become 1. Now, so this will be 2100. So 2100 grams per ml. Look at 2100, how many significant figures are there? 2. Now none of my choices is 2100. Then what I'm going to do, I will convert this into the scientific notation, because I can see some of the numbers are given in scientific notation. So I have to have my decimal between first 2 non-zero numbers. So 2100, if you cannot see the decimal, it is at the end. So now you're moving the decimal to the 1, 2, 3. You're moving decimal left 3 places. If you're moving decimal left 3 places, then your x is positive. Keep in mind that when you have something in standard form and you are changing it to the scientific form, your number of significant figures should stay same. Here there are 2, and here there are also 2. So 2.1 times 10 to the third grams per milliliter. Next is the specific gravity. Specific gravity is basically compares the density of a given substance with the density of water. And if I have density in the numerator as well as in the denominator, then what's going to happen? The units cancel out, and that's why we say the specific gravity is equal to the density of but with no units. Now, since the density of water is 1 gram per ml, that means specific gravity will be equal to its density, but no unit. So the point is, for example, the question, let's say the question is specific gravity of isopropyl alcohol is 1.009 grams per ml. I'm sorry, density of isopropyl alcohol is 1.009 grams per ml. What is its specific gravity? So all you have to do is to take this density value, density of the substance, which is 1.009 grams per ml, divided by the density of water, which is 1.00 grams per ml. These will cancel out. So your answer is 1.009. So you always have to write down this answer, but with no unit. This part, accuracy and precision, we're going to discuss it in the lab. The temperature it's a measure of how cold or hot the object is. These Fahrenheit, Celsius, and Kelvin, these are the 3 different scales to measure the temperature. Now in this one, you can use this formula. If the temperature is given in degrees Celsius, you plug the value here to find the degree Fahrenheit value. If it is given in degree Fahrenheit, you use this formula to find degree Celsius, and then you can use this formula to convert degree Celsius into the Kelvin. Let's do some measurement practice. You do not have to submit this. This is just for the practice. For example, these are the rulers, and let's say you're measuring the mass of this object, the one this here, and the question is what is the length of this object. So first thing, its length is between 3 and 4. So what you do, you take these numbers, 4 minus 3 equals 1, and then there are 10 lines in between. That means you're dividing this 1 into 10 equal parts. That means each part is worth 0.1. So that means it will be 3.1, 3.2, 3.3, 3.4, 3.5, 3.6. We are certain about 3.6. But we can see it is somewhere between 3.6 and 3.7. So we say our estimate will be 0.01. Means we're going to put one more digit here, and that will be our estimate. And if you look closer, then I put for this as 3.67. The point is that the measurement should have some estimate at the end. 3.6 we were certain, so we're going to put one extra for the estimate. That's what it makes the measurement. Look at this. Here it is between 6 and 8. So 8 minus 6 is 2. Again, 2 is divided into 10 parts. So each part is worth 0.2. 2 divided by 10 is 0.2. So that means 6.2, 6.4, 6.6, 6.8, 7.2, 7.4. We are certain about 7.4. Means we are certain up to one decimal place. That means one number after that is going to be my estimate. So then you basically, again, what you do, since it is between this and this number, you think of the 10 equal parts in between these two, and then put the last number as your estimate. You can try these third, fourth, and fifth to see if you can do how to find the measurements. But this is just for your practice. You do not have to submit it.